So let's do an example on string tokenization in C#. So we're going to open a project. It's going to be over here a C# project. Let's call it tokens and click on next, and we're going to use the .NET version 5 for this example. You can use 6, whatever you want that you want. And on create, we're going to have this simple program over here. I'm just going to put an example string str is equal, so this is a test. So what is tokenization? Tokenization is a feature in C# and many other languages that is basically breaking up something into tokens. In this case, we're going to break up this string into tokens, and the token is, this is a token, and this letter A is a token, and this is a token, and this is a token. So basically, I hope you figured that the separator or the delimiter between the tokens is this thing, which is the white space. So between each white space there's going to be a token. Let me open my small tool over here just to make sure that you can see my mouse pointer. So how can I do that? So let me write a line. So if I do write a line over here with the string, basically, it's going to be the whole line. This is a test. In order to break it, I'm going to use a method called split that is part of the str reference object. So this object that is str referring to has a method called split, and if you look at the split, what it does, so it's heavily overloaded, but what it does, one version of it is basically, and you can see all of the versions over here, is basically getting this string and returning an array. I hope you can see this string and array of strings. So this is going to return an array of strings. So I'm going to assign it to tokens. I'm going to name this array tokens. So I'm going to give it this notation, and tokens is equal to string or str.split. So this is going to have this in its token by itself. This is a token by itself. So tokens of 0 is going to be equal to this, tokens of 1 is going to be equal to is, and tokens of 2 to a, and tokens of 3 is going to be equal to test. So let me put a for each loop. So you see, so here it is for each string token in tokens. What I'm going to do is I'm going to output token over here, and let me execute. And as you can see, because this is a right line, this is a token by itself, is a token by itself, a is a token by itself, and test by a token of itself. You want to see see it in action, or without, just put a break over here, and F5. I just wanted debug mode before we execute the line. If you want to see the tokens array, which is this one, so tokens of 0 is this, and tokens of 3 is going to be equal to test. Let me stop the debugger, and this is basically initially how things work in tokens. Now, why is this so nice? Let me just get a more realistic example over here, and instead of this guy being over here, let me call it an expression. So this, I'm going to call this, I'm just going to refactor it or rename it to expression. So I'm going to rename it to expression, and this expression is going to be a console.readLine. So we're going to read the line from basically the user. And again, if you do it this way, I'm just going to execute whatever this is. And again, so anything that you're going to write is going to be in tokens. So this is not what we're going to do. So what we're going to do is actually something more, something better. Can we use split to calculate the results of an math? So it's basically just a math expression. Basically something like this, 1 plus 2. Make it 1.5 plus 2. Can we do that? Look at it guys. Here's what I'm going to do. 1 plus 2 multiplied by 9 divided by 8. And I don't care about precedence over here. I'm just going to go from left to right. Again, this is from left to right. We're not going to go from whatever. We're not going to go through priority, which is basically this has priority. So left to right, 1 plus 2 is going to be equal to 3 multiplied by 8 by 9, I'm sorry, going to give me 27, divided by 8 is going to give me a fraction. So we're going to do that. How can we do that, guys? Now, here's the thing. Before I show you how we do this, look at the tokenization. Can we do this 1 plus 2 plus 3? And if I press enter, it's going to be just one token, which is 1 plus 2 plus 3. Let me just show you when I do this. When I press F5 and 1 plus 2 plus 3, enter, and as you can see, the tokens are just tokens of 0 is going to be equal to 1 plus 2 1. There's no multiple tokens. So how can I do it multiple tokens? Now there's a trick. In split I can specify an array of characters, and this array and characters, like inside over here, is going to be my delimiters. So here's what I'm going to do. At the beginning I'm going to say character, and I'm going to make it an array, and I'm going to just call it, for example, splitters. I can call it operators, but I'm going to splitters, and is going to be equal to all the splitters that we have over here, which are going to be the plus, the minus, or subtraction, and the multiplication operator, and the last one is the division operator. Now if I do this and I say, well, this is going to be depending on splitters, it means that whenever we encounter splitters, it's going to split the tokens. Now let me execute and put 1 plus 2 plus 3, that's not 3, this is 3, and press enter. As you can see, 1 is by itself, so tokens of 0 is going to be equal to 1, tokens of 1 is going to be equal to 2, and tokens of 2 is going to be equal to 3. Now, can I put more than one number? Yeah, sure. If I stood 20, whatever this thing is, plus this thing multiplied or divided or multiplied, and then again plus, and press enter, all of these are going to be separate tokens because we have this plus over here, the division, the other multiplication, and the plus over here, as you can see. Now, why am I doing this? Because we want to try to split the number, and we did over here. So this tokens actually has the numbers. So rather than tokens, I'm just going to refactor it and call it numbers. Let me just exit the program and just rename this guy, and you know what, I'm just going to call it values. So I'm just going to call it values over here just to make my life easier. So we have the splitters, we read the line, in this line of code we split the values into an array called values, but we still don't have the operations between each value. So basically, if we enter 1 plus 2 by itself, we know there is a 1, we know there is a 2, but what about the plus? So let's do this. Let's create a list, guys, and a list of type character and of type character, and this list is going to contain an operation. So it's a list of operations. Let me call it operation because it contains operation. So new list of character, and that's what I want to do it. So like this, and don't forget the constructor. So this is the type that we're doing it. So in this list, I'm gonna do something really simple. I'm gonna iterate over the expression that we have and record every single operation. And in order to do that, I'm gonna use a for each loop like the one beneath. For each character C, not in values, it's gonna be an expression. What I'm gonna do is basically I'm gonna check, I'm gonna add if I see a plus or a minus or a division or a multiplication. So if that C, let me do this, if that C is equal to a plus, or the C is equal to, and I'm just going to copy and paste because we're over here, if it's equal to a minus or equal to a division or equal to a multiplication, so this is a multiplication, a division, and this is a minus. So if that's the case, what I'm going to do is that I'm going to add this operation C to the list of operations. So this is what we have so far. Forget about this line. This is what we have so far. So we read a line over here. So we read a line from the user. And let me put this line at the beginning, even though I don't like this habit, but I'm going to, over here we're reading. reading from input, which is the console, basically the user. Okay, and over here we're defining our splitters. Over here, create an array with all values, which is this line. Over here, create a list with all operations, which is this guy over here, and we add the operations over here. Now what we need to do is that we need to apply an operation on values. Let's take the simplest case. The simplest case, if the user enters something like this, just a number without any operation. If the user does that, basically it's just the number itself. So that's what we need to concern. So that number is going to be the result of the operation. So with that, with the word, I just used the word result, I'm going to define a double result equal to, what is the result? The result at the minimum should be the first number that is typed in. So it's going to be equal to the first number, so which is double dot parse, not operation, which is values of 0. What is values of 0? Values of 0 is a string that holds the first number. So we have to convert the string into a double. There's multiple ways. The correct way is to do it is to use a try parse, but I'm doing it over here just to show you. This is an example about using tokenization, not about anything else. So yes, it's not perfect, but it's just a proof of concept. So I took the first number. Now we need a for loop for the other numbers. So I'm going to do a for loop with integer I equal all the way from 1 all the way to the whatever value. So 1 is the second value. And here's what I'm going to do. Inside this over here, I'm going to take the second number. I'm going to start with the second number. And again, the second number is at I. Okay, the second number is at I. And if I put temp, I'm going to say double temp over here. I'm just going to put a temporary variable, which is going to hold the value that we're going to parse. Again, the first I that we're going to encounter is the second I. Now, if I take the first value, which is stored in result, and the second value is going to be stored in temp, what I need to do before I apply the multiplied by 9, I need to add them together. So the way that this works, we take two values at the time. So this by itself, we took it over here, take the first value, and this is result. Then we take this result, which is 1, add it to 2, which is 3, and then this whole thing becomes as a result. Then we take the 3, which is the result, and then add it to, or multiply it to 9, which becomes 27, and so on. So every time I'm just taking the number that we're seeing and doing the operation that we're doing. So now we need to determine what kind of operation. So in order to do so, I'm just going to use a simple switch statement. And this switch statement is going to be based on the operation. Now the operation is a list, so it's going to contain operations. And let me just go back and say 1 plus 2 over here. So the list of operations in this case is going to be 1 and multiplication and division. And this is going to be at location 0 in the list. This is going to be at location 1, and this is going to be at location what, guys? At location 2. So over here, when you think about it, yeah, I'm going to deal with the first number, but I'm going to need to deal with the first location of this operation, which is at index 0. So I'm going to say switch of operation, and I'm going to be clever, and I'm going to use I minus 1. I minus 1, remember I begins at a 1 over here, so I minus 1, basically we're beginning at 0. And let me just put brackets so it doesn't give me a hard time. So we have this case of what is it, what if it's a plus? So well, I'm going to say result is equal to result plus temp, because it's what, guys? It's a addition. And I'm just going to add, just going to copy and paste and do this. This is a minus, this is a multiplication. Let me scroll up just a little bit, and this is a division, and let me do the corresponding things over here, and this is a division. So right now what I did is I'm actually taking each value, parsing each value, and seeing the operation associated between the result. See what I'm updating? I'm always updating the result, because again 1 plus 2 is going to be equal to 3. This is going to be replaced with 3. Then 3 multiplied by 9, this is going to be 27, and so on. And the last thing is going to be the result from 27 divided by 8. And the last thing that we need to do at the end, I just want to make sure that we're doing it right. So I need to display not token, I'm going to display the result, guys. So let's see if we have any issues in this program. If we do, we're going to basically debug, and let me execute. Again, this is not a pretty program. There's no user prompt saying enter the expression. That's what you need supposed to do if you're doing it correctly. Let's start with something simple, which is 1 plus 2, and 1 plus 2 is surely equal to 3, so that's nice. What about 1, not 1, why am I in 1? 5 multiplied by 9 minus 3, which is going to be equal to 42. So as you can see, it's working. So it's working because what we're doing is the following. We're using the split as a string tokenization, and we're putting all the values inside over here. We're using a list, putting all the operations inside that list, then applying an operation on the values and the last result that we have. Again, we initialize the result with the first number that has been entered. Now, is this going to work if I do just the number 5 by itself? Yes, it does, because the for loop won't even iterate in this case, because the values.length is going to be equal to 1, and this is less than, not less than or equal. If you have any questions, any comments, let me know in the comment section. I'll be happy to answer.